So we've got this elliptic paraboloid. Okay, it's an ellipse in any plane here. It's a little wider than it is front to back from your perspective. If the x-axis is this way, y-axis is this way, z-axis is this way. So we have this thing, and now we've let x be 1/2. Now the vertex is here, let's say, okay, right here at 0, 0, 0. So x equals 1/2. We come out a little bit in front of the vertex and make a slice, and we get this parabola that's a little bit above the xy plane, 1 unit, the vertex being 1 unit above the xy plane. And the parabola having this equation in y and z. Okay. Now, what if we wanted some point on this curve? Let's say the point where y equals 1. Okay. The point where y equals 1 might be out about here. We come up to the curve, we're here. Okay, so x equals 1/2, y equals 1, maybe we're up here. And that actually makes a bit of sense. X equals 1/2, we get 1 here. Y equals 1, we get 9 here, so we're up 10 units. Okay, so now we're slicing this thing. We've sliced it a little bit in front of the YZ plane, half a unit in front of the YZ plane, and got a parabola. Now we slice it 1 unit in front of the XZ plane, and that parabola gets sliced maybe right here. Okay, how does the surface behave in the neighborhood of that slice? Well, as far as the x direction goes, if you move from this point in the x direction, you're going to be moving along this parabola of intersection. It's going to be pretty steep. You're going to have a certain slope. Well, you can get a vector out of that. The vector is in the y direction and the z direction. It's going to be some multiple of j plus some multiple of k. And that multiple of k will be much bigger than the multiple of j because this thing's very steep. If we find that the slope of this thing is, let's say, 20, then the vector 1j plus 20k is going to be tangent to this curve. Now we slice in the parallel to the, okay, do it here, parallel to the xy plane, we get another parabola that intersects this parabola at that point, at the point 1/2, 1, 10. And that parabola has maybe a little different shape. It's not stretched as much because the coefficient of x is less than the coefficient of y, and you can work out the details of that. You don't have to worry about those details right now, just giving you a picture. So now you've got a parabola here, and at this point the parabola is steep in this direction. It's not as steep as this one, so if this one has a slope of 20, and it doesn't have a slope of 20, you can figure out the slope easily enough, but we leave that for another day. Whatever this slope is, we can have a vector I plus whatever the slope is times k, and we match that. So now we've got this vector that is tangent to this, to the parabola we get with this slice, and this vector that's tangent to the parabola we get to this slice, and these two slices meet at this point of the graph, so now we have two vectors that are both tangent to this surface, and we can take their cross product and get a normal vector, a vector normal to this surface. And that ties this in with chapter 3. Now, all the details of that, well, you work through them one at a time, systematically, and it's not that difficult of a picture. One other preview. If we want the rate of change as x changes, that would be the rate of change in the y in the x direction. We take a derivative of this expression, treating x as our variable because it's x that's changing, treating y as constant. Well, then the derivative of x squared y will just be 2xy, treating y as a constant, treating x as our variable. And the derivative of y squared is going to be 0 because y is constant, being treated as a constant here. If we want to know the derivative in the y direction, how a change in y affects the value of the function, then we treat x as constant and take derivative with respect to y. So the derivative of x squared y would be just x squared. The derivative of y squared would be 2y. Now we'll say this again slowly, but it's a pretty simple concept, and if you get it right now, you're going to be a little bit ahead. But you're not going to be in trouble because it's, again, if you don't understand it now, you'll understand it when we do it a little more systematically, a little more slowly, and you'll also understand how it relates to this picture of slicing in this direction and slicing in this direction. A picture that we need to develop a little more slowly than I've presented it here. But I do want to get the wheels turning on this picture of a graph and the idea of slicing the graph, because this is central to the content of Chapter 4.